Okay, all right. So we're going to run here. And if you know, this is Newton's laws. We're just going to move as fast as possible. Like I said, these are things that always challenge learners. We get the principles right, and we just take off good flow on that. A group of learners designed a device that consists of a light ball on a string hanging from the roof of a cargo truck. Now, this question I pulled from a grade 12 paper, which is the one they wrote this year. But it's all grade 11 concept. The device is used to determine the acceleration of the truck. When the truck is stationary or moving at a constant speed, the ball will hang straight down. I want us to read that again. When the device is stationary or moving at constant speed, the ball will hang straight down. There's something common to this statement. There's something common to that. Stationary and moving at constant speed. Apart from Newton's first law, there's a constant variable. Anybody wants to help me? There's something connected to both of them, or there's something connecting both of them. Object is stationary, it's Newton's first law, but when the truck is stationary or moving at a constant speed, the ball will hang straight down. Something is common. Lovely. Zainab, the net force is equal to 0 at both points. Why? At constant speed, and at stationary point, acceleration is equal to 0. Therefore, F net is also equal to, so that is common to the two scenarios. All right, the ball will hang straight down. But when it is undergoing a constant acceleration, the ball hangs down at an angle as shown in the diagram. What we need to check is, why is the object, when the object is moving forward, like you see the arrow, this thing moves backwards. This is because of Newton's first law. That when an object will remain at rest or continue in uniform motion unless an external. And remember, also due to inertia, the object wants to remain there. Okay? But object is moving forward, so it has to move backwards because of inertia connected to Newton's first law. Draw a free body diagram of all the forces acting on the ball. Quickly, everybody, 30 seconds. A free body diagram of all the forces acting. 30 seconds. We should be done. How many forces are acting? Do you want to give me a list? Those of you at home, online, give me a list. What forces can you see here? Dash, what force do you see? And? Weight and force applied. There is no force applied. The force applied probably on the device, but the question says force acting on the ball. I would rather say, Dash is saying tension and the weight. So the object has a weight, and then we can be specific by saying tension. All right? Zainab, did that make sense? So if we were to draw, tension is that way, and Fg is this way. So we have force of gravity, and we have tension. Okay. I hope everybody's okay. Now, one thing I notice here automatically is that there is a force, all right, that is not a vertical force. Remember in physics, we want to try as much as possible to work with vertical forces and horizontal force. But I am looking at my tension right now. It is not a vertical force. So what do we need to do? we need to automatically change it into vertical and horizontal, which we call components. So if I were to go to a new page quickly, so let's do our free body. We said our tension is acting this way, and our weight. Remember, there must be a dot there. So this is weight, or which we call the force of gravity, and we have what? Tension. Now, let us change this into vertical and horizontal. The weight is fine, being a vertical force. But what happens? The tension. We have the vertical and the horizontal. And the vertical will be going up, and the horizontal will be going left. I want to ask if we are all okay with TY going up and TX going left. Please talk to me. Are we okay? Let me know yes or no. Or you're not sure of the directions. Please quickly. We are okay. All right, I see everybody's saying yes. Great. Lovely. The next thing is to be able to find the formula for TY and TX. All right. How do we get the formula? You need the angle. I'm going to go back to my free body, my question, original question. Check. Do you notice that if I were to draw that same free body diagram, I'll use a blue. This is, we said it went that way, right, to the left, and then it went where? Up. Automatically, we have a right angle what? Triangle. And you would notice this is horizontal on the X, TX, and this is vertical, TY. And I always just simplify to say the one that is opposite, what do we use? Sine. Just make it simple. And if you don't want, and this is your tension, you can just use your trig ratio, sine and cos. But I know now that if I were to say sine, let's walk through. Sine theta will be opposite, which is what? Tx over hypotenuse, which is what? T. So what is this? Tx equals to what? T sine theta. Please let me know if everyone, or if you have a question, T sine theta. What is Ty therefore? Ty will be T cos theta. Very important that we quickly, that's where we start physics from, interpreting your free body diagram correctly, your components correctly. Once you are able to get the formulas right, the rest of the game is so easy. Now check. It says in this case, the mass of the ball is 50 grams. I've got a big problem there. This is physics. We don't work in grams. We work in kilograms. So how do we convert? We divide by what? How do we convert grams to kilograms? We divide by 1,000. And this becomes 0.05 what? Kg. Okay. Now, we also know the angle. Angle is what? 18. The question says, first one, calculate the horizontal force on the ball. Calculate the horizontal. Can we name, okay, our theta is 18, right? Let me write that. Mass is 0.05 kg, and our angle is 18 degrees. Can I ask you to calculate? I'll give you 4 minutes. There's no need to go back to the question. We are looking for the horizontal component. And I want to try for me, using your knowledge of physics, your trig, your maths. We are looking for, number one, horizontal component. Horizontal component. Let me get the full question. Oh, calculate the horizontal force on the ball. Calculate the horizontal force on the ball. Everybody, 3 minutes, 30 seconds now. Quickly. I have done most of the work for you. 3 minutes actually. Okay, let's say. 3 minutes, 30. This is grade 11. Let's try. Horizontal force on the ball. Remember that you do not have tension, so don't be overwhelmed. Find a way. Use your knowledge of forces to deal with this. You do not have tension. Once you are done, put your answer on the group chat. And if you are lost, just let me know. Lost, stuck, And if you get an answer, please put it in. Either you are lost, you are stuck, or you have an answer. Two minutes left. I'm not seeing anything on the group. I guess we're still busy. Okay. All right. I see two answers. Dash, what's your own answer? Okay, Dash has 0.17. Zainab has 0.52. Mm-hmm. 0.015. That's a third answer. All right, guys, let's look at this together quickly. So, one thing we know that the object is moving horizontally, right? That's how the object is moving. Please take note. When the object is moving horizontally, it means that the vertical forces are at equilibrium. When we have a horizontal movement, okay? So just take note of this. For horizontal movement, it means the vertical forces are at equilibrium. And you would notice there are two forces here that are in opposite direction. I see a lot of answers. Jalen gave me another one, 0.06. Okay, let's see who's correct. It means that by vertical forces are equal, right? So what does that tell us? T cos theta equals to mg. Okay, hold on. By the way, the examiner wants us to calculate horizontal force. What's our horizontal force? Tx, which is what? T sine theta. The problem is we don't know T. Where are we going to get T from? Oh, I'm going to get T from where? Vertical forces. Because the vertical forces are at equilibrium. Okay, let's see. Do we know everything? We don't know T. Cos what? 18. Do we know the mass? And what is G? Oh, guys, do you see that we can get our T from here? Easily. Easily. So what is T? 0.05, 9.8 divided by what? Check what I want to do. I don't want to round off, so I'm not going to calculate. Can we bring that here now? But Tx, which is what we are looking for, is T what? Sine theta. Now do I know my T? What's my T? 0.05 multiplied by 9.8 over what? Cos 18. Everything multiplied by sine 18. Put that in your calculator and tell me your answer. What do you have, Dash? Is it 0.16? 2 decimal places. I don't know who got it right at the first go. Let me see quickly. Let me go back to your answers. 1/6 rounded off. Oh, you got it right. Regan, I don't know what you did. You got 0.17. Oratili, I don't know if you missed something. You got 0.015. Okay, Hamza got 0.49. Okay, Noella was lost. Jaylene got 0.06. But I don't know if it makes sense. Okay, there she's saying acceleration is 0. It's not 0. The object, no, you didn't read the object. So when the object accelerates. Okay. Okay, Jaden, I'll get you. So the thing is, I didn't multiply by cos 18. All right. Zainab, why is the horizontal also part in... No. The horizontal is not part of the equilibrium. Let me deal with all your answers. The horizontal is not part of the equilibrium. My equilibrium is this. T cos theta equals to mg. This allowed me to get T. So I got my tension. Remember, we don't have tension. The horizontal force is T sine theta. I cannot get that without getting T. But there's no way I'm going to get T if I don't equate the two of them. So I have to say T cos theta equals to mg. Why? The object is moving horizontally. The vertical forces are at equilibrium. So we equate these two. These two are equal. T cos theta and mg. So T cos theta equals to mg. And I know my angle, 18. I know my mass. Divide both sides by cos 18. This is tension. The reason I'm leaving it like this is because I don't want to round off. All right? So this is T. And all I did was to bring that T. T sine theta. What is T? That is T. It comes here. That's my T. Sine theta, sine 18. And it gave me that. Okay, I don't know if Zainab, you're fine, Jaylin. I don't know if you're okay right now. Made sense. Okay. Jaylin, talk to me. Our next question. Okay, Jaylin, I'm waiting. Oh, you got it. Beautiful. Lovely. So, Desh, you also got it wrong because remember, for us to get check, it says when the ball is stationary or that, it is hanging down. But when it is now moving, it is this way. So the fact that it has gone this way means it's moving. Acceleration is not zero. If acceleration is zero, it should have been hanging down. So the fact that we see this movement simply means that acceleration is no longer what? Zero. Check the next question. Everybody, calculate the acceleration of the truck now. Let's get A. 3 marks. This is now easy. Let's get A, quickly. Let's get A. Guys, we should be done. There's only one way to calculate acceleration. Guys, use the direction of motion. Which force is causing the object to move? It is the horizontal force. The object is moving horizontally. So use your horizontal forces. And which one is the horizontal force? Tx. So what do we say? I thought you would be done here by now. Number 2 is to calculate what? Acceleration. A. So what do we know? F net is equal to ma. But which F net? It's just this. So Tx is equal to ma. And we're done. What is Tx? 0,16. What's mass? 0,05 multiplied by A. What is A? 3,2 meters per second what? Squared. Are we looking for magnitude? Let's see. It says magnitude. It means we don't need direction. I hope we are all okay. Zainab, how are you getting 0,99? What did you do? Send me a picture of your solution. I want to check quickly. Quickly send me on WhatsApp. You have 10 seconds. I want to see what you did, how you got your 0.99. Quickly. And guys, are we okay? All right, thank you. Zainab received. I want to check. You said T sine 18. Why? Okay, let's see. You're making a mistake. I see your mistake. You see, Zainab, you said T sine 18. What is your tension? I want us to differentiate. Look, this is my tension. Can you please calculate tension for me here? This is my tension. You used the wrong thing. 0.16, it's not your tension. 0.16 is your horizontal force. 0.52 what? No, give me 4. I want 4 decimal places. Yeah. Yep. All right, guys. This is our tension. Zainab, I want you to see. All right? That's our tension. Okay, you're fine now, Jelin. So I lost because I got a different answer. Okay, Oratile, are you okay now with what I did? Let me claim this and go to the next and go to a different page. I want us to get what we got. Tension is 0.5152. But horizontal component is 0.16. All right? So if I am looking for, what am I looking for now? Acceleration. Let's try to create a different page quickly. If I'm looking for acceleration, what would I have? I know that F net is equal to what? MA. But what is my F net? I wanted to check. Is either you say TX equals to MA, or you say T sine theta equals to what? MA. T and TX are two different forces. They have different values. What is TX? 0.16 equals to what? MA. Oh, we already know our M, right? Let's save time. 0.05A. What is A? 3.2. If I don't want to use that, Zainab, this is what you did now. T sine theta. What is your tension? 0.5152 sine 18 equals to what? 0.05A. I promise you when you do this and you round up, you are going to come back to that. I don't know if you see your error. Oratile, are you fine now as well? Okay. So this is us getting Newton's laws right. I'm going to run through the next question quickly. Let's see the next one. This one, guys, is 8 marks. The first 5 marks, I am going to give you 6 minutes. I'm not even going to say a thing, a word. I'm not going to read for you. I don't want to interpret. I'm not interpreting for you. 6 marks, I'll talk to you at green, green, green. All right, guys. Okay. I'm seeing. All right, so Zainab, you have two answers. Let's see. Quickly tracing up. Tesmia 1515 and 12,94. Let's see, Zainab, do you have the same answer? 1515, 12,94. Block A, 1515. All right, Texin, you gave me one answer. All right, Tane, 1515, 12,94. Lovely. Bibi, don't start with your solved again. Okay. All right. Dash, what are you getting? You cannot solve this without a free body diagram. Again, we always sketch our free body what? Diagram. Okay, if you check, A and B below are two identical blocks, each with a mass of 5 kg, joined together by a light inextensible string. The blocks are pulled by a force of 65 Newton at an angle of 40 to the horizontal. The two blocks accelerate to the right at 2,17 meters per second, and the tension is 26. Calculate the friction on each block. So we expected to get two answers. Now, you cannot calculate effectively without drawing what? A free body diagram. So let's quickly do a free body diagram on A. Let me do this so that we get a very, very good picture. There we go. So, if I want the free body diagram on A, let's check. What are we going to have? A dot there. What forces are acting? Normal. What else? Gravity. Friction to the left. Why? Object is moving to the right. And there's a tension force there. Oh, sweet. Tension, friction, normal, and Fg. Take the direction of motion as positive. So tension becomes positive, friction becomes what? Negative. We are done. Object is accelerating at 2,17. So what do we know? F net is equal to ma. I told you earlier on, when the force object is moving horizontally, let's focus on the horizontal forces. All right. How many forces do I have on the horizontal? 2. Positive T plus negative what? Friction equals to what? Ma. Do I know my tension? 26. Do I know friction? No. What is the mass? 5. What's the acceleration? 2,17. And we are done. Give me an answer. 5 times 2,17, and then we move the 26 over. Let's check quickly. 5 times 2,17 equals to that. And then we move the 26 over, minus 26 would give us what? Negative 15,15. So negative would divide each other. We have what? 15,15 newtons. We're done there. We go to the second object. Now, the second object now is similar to what we did earlier on. What forces do we have on the second object? Quickly, we have what? Normal force. We have Fg, which will be a bit longer. We have this one this time around, force applied. Now, there's friction this way. There's also tension. I need us to get those free body diagrams correct. Tension, friction, normal force, force applied, and your Fg. But I said earlier on, when we calculate in physics, try to calculate with what? Vertical and horizontal forces. So all of these are the same, except for one, which is what? My applied force. So I'm going to have Fy, vertical, Fx, horizontal. But we still have what? A normal force there. All right? Good. What force do we have here? Friction. What do we have? Tension. And what do we have here? Fg. So it's well stated. Fg there. Force applied, Fx. Normal. Force applied, Y, vertical. Friction. And then we have what? Tension, which is what? 26. But the object is moving to the right. Right? And then other ones will what? Left, left. Negative, negative. We use the same principle. But now the question is, what is my Fx, horizontal? Always go back to your diagram. It's always easier from there. Right, and up. The one facing the angle, we use what? Opposite. So this is going to be what? 65. The one opposite, we use what? Sine. 65 sine 40. That is Fy. What is Fx? 65 cos 40. Get your trig ratio correct. So what do we have here? F net equals to MA. Which forces do we have? Fx plus negative tension plus negative friction equals to what? MA. The rest is just maths. Do we have Fx? We did that a while ago. 65 cos 40. What's my tension? 26. Minus friction. What is the mass? It is 5. And what is acceleration? 2,17. And we're done. Calculator. Let's run. 5 times 2,17 equals to that, right? Now, minus 20. No, take the 26 over. It becomes what? Positive 26. Positive 65 cos 40. Close the bracket. What do we have? Did I do this right? Is it 86? This is too much. Let's see. Is there a mistake? I have moved it over to that side. What do I have? 5 times, let me check. Maybe I made a mistake there. 2,17 plus 86,64. Is this what you guys have? Okay, wait. Why am I making my error? Oh, no, I see. I took the 26 over. All right, I see. 26 over, I took it over, it becomes positive. But the 6 cos was positive here. It's supposed to be what? When I take it, I'm already taking everything over. All right, I see my error. All right, which is negative 12,94. And by the time I divide both sides by negative, I'll have what? 12,94 Newton. So you were right, guys. It's basic and simple. Okay, thank you. Sorry, just now. All right, so we have 12,94. Do you notice the frictions are different? But the object they have the same mass. And that's why the examiner is asking you the next question. Explain why the frictional forces on the two blocks differ. I did something similar to the grade 12s yesterday, and I tried to explain what is responsible for friction. All right, one thing we must know is friction equals to what? Mu K N, which means that friction is directly proportional to what? Normal. The bigger the normal, the bigger the what? The greater the friction. I don't remember which object. Now, which one has, let's look at the normal for A and B. Look at the normal force for A. Normal is equal to what? Fg. So for A, I hope it's making sense. For A, normal is equal to mg. What about for B? How many forces are pointing up? 2. How many down? 1. Remember what I said? The object is moving horizontally, so the vertical forces are at equilibrium. So N plus Fy equals to what? Fg. N plus Fy equals to what? Mg. What is N here? Mg minus Fy. And you can do the calculation now if you want. What is the mass? 5 and 9,8. This will give us 49. What about this? 5 times 9,8 minus, what is my Fy? 65 sine 40. Do you want to give me an answer? Quickly. You would see that my normal forces are not the same. Seven, 22 newtons. Guys, do you see that my normal forces are not the same? The greater the normal, the greater the what? Friction. Let's quickly go check our answers. Which one has a greater normal force? A. So the friction of A should be bigger. Let's confirm. 15,15 compared to what? 12,94. All right. So if I want to answer this question, I'll start by stating this formula. All right. So I'll say, okay, let me put my answer here. This is the calculation. What would I say? I'll say for the same coefficient of friction, all right, a greater normal force will have a greater friction. The upper, I'm going into details now, inclined applied force, upper, inclined, very important, all right, reduces the normal force because of its vertical component, because of its upper direction. I want you to understand this. Vertical what? Component. Hence, a small friction. Because friction equals to mu k normal. Please, this is an application question, and I try to make the explanation detailed just below. I hope we are okay. Did it make sense? Just give me a thumbs up, a thumbs down. Confused, I don't understand. I don't see what's going on. I can't see the board. I don't hear you. I don't understand this physics at all. Okay. I should explain upper incline. What? Okay. What it means is, okay, let me just wait for, give me a few seconds. I see some people are writing here. I want to quickly show you what it means when I say upper inclined force. Upper inclined force. And this, whatever I'm doing right now will also be needed when we get to electrostatics. All right. I wanted to see this. I wanted to say this. If I have a force this way, and I have my normal this way, and I have my FG this way. So my force, do you see it's pointing upwards, right? When I resolve this, what am I going to have? That. I'm going to have that, right? And I'm going to have that and this. Fx, Fy, normal, and Fg. I want you to see this. What am I going to have? N plus Fy equals to what? Fg. N equals to what? Fg minus Fy. All right. Let's compare it to this one. Compare it to this one. Now, instead of having the force going up, I am actually having it. So you are pushing it. This is you pushing a trolley. This is what happens when you push a trolley. I have my normal force and I have my Fg. So you are pushing a trolley. F applied and normal. Can we draw the free body? Can we change the free body diagram into components? What would I have? I have my normal. I have my Fg. But what would happen to my F? Horizontal would go to the right. But where will vertical go to? Down. All right. It will go where? Down. Why? It's not an upper inclined force. It's a downward inclined force. What do we have here? Fg. What do you have here? Fy. What do you have here? Fx. What do you have here? Normal. Vertical forces are at equilibrium. So what do you have? N equals to what? Fy plus Fg. Let's call this object 1, or let's call it X and Y. Or let's call it what? P and Q. I don't want to use the same letters. P and Q. I want you to notice something. Which one would have more friction? Q would have more friction. Why? The normal force is bigger because I am adding. Check this one. I am saying Fg minus Fy. The one on the right, Fg, okay, let's write it the same way. Fg plus. This one would have a greater normal force. Therefore, a greater what? Friction. I don't know if I was able to get you there by what I mean by upper. This one is an upper inclined. And this is a downward incline. So here you are actually pushing downwards. This is what you do when you go to the mall. And here you are pulling. So actually when you go to the mall and you buy stuff, it is easier to pull your trolley than to push. It's only not safe after paying. After paying, you're pushing, saying you are doing physics. Oops, sorry. All right. And I hope everyone is also able to relate to that as quickly as possible. So your answers are always in the free body diagram. Answers are always in the free body diagram. Okay, let's go. I want to have fun again. Let's answer these 2 marks. Easy. This one is 2 marks. Which one of the following physical quantities is a measure of the inertia of a body? It's 2 marks. You should know your answer by now. Inertia is the resistance of an object to change position. Just going to define that. The resistance or the property of an object, the resistance of an object. All right? Or let me say property to resist change. Let me just make it nicely. Property to resist what? Change. Property to resist change. So what's your answer? Do you want to type that for me? Property to resist change. I'm waiting, guys. I thought you guys are already done giving me an answer. Quickly. All right. The correct answer. Tasmia. The correct answer is A. It's mass. The bigger the object, the more difficult it is to resist. So the bigger the object, the greater the what? Resistance. Okay? The bigger the object, the greater the resistance. Lovely. We're good. Oh, electrostatics. Let's move. The distance. Okay, now this is similar to what? Newton's law of universal what? Oh, this is not electrostatics. Actually, Newton's law of universal gravitation. But it's similar to what? Electrostatics. The distance between the centers of 2 planets, centers of P and Q is R. Check the diagram. The mass of P, guys, when you do physics, just like maths, I want you to learn to change the words. The mass of P is twice that of Q. Let's change that quickly. The mass of P, the word is means equal to. Twice that of Q, 2mq. Very important. And you can even see the sizes. Examiner tried to make it bigger. Consider the following statements regarding the gravitational force exerted by the planets. The force will always be attractive. The force exerted by P on Q is twice that exerted by Q on P. The force that the bodies exert on each other is independent of their masses. The force exerted by P, guys, we are not going to go to A, B, C, D. Okay? We're not going there. The force exerted by P on Q is equal in magnitude but opposite in direction to the force exerted by Q on P. All right, let's quickly, you got to go fast here. The first one, is it correct? The force will always be attractive. We need to state the law of universal what? Gravitation. What does it state? The first line says that all particles in the universe attract each other. all particles attract what? Each other. So, 1 should be correct. The force exerted by P on Q is twice that exerted. If object A exerts a force on object B should do what? Exert what? A force back on object A, which is equal. We said 1 is correct, right? Objects will always, this is not electrostatic, we talk about charges. All right? So, force exerted, this one is wrong. Why is it wrong? According to Newton's what? Third law. All right, let's look at the third one. The force that the bodies exert on each other is independent. Do you understand the word independent? It means does not depend. And that's not true. It depends. Why? The force is directly proportional to the product of the masses, which means bigger masses would have what? A bigger force of attraction. So this one is also what? Wrong. The force exerted by P on Q is equal in magnitude, yes, but opposite in direction. This is our Newton's what? Third law. So which answers are correct? 1 and 4. Is it there? Yes, C. So when it comes to this question, please, the laws must come into play. And I hope you understood how I interpreted the law. All particles in the universe attract each other. That was my first one. With a force that is directly proportional to the product of the masses. That was why I was able to cancel out number 3. And inversely proportional to the square of the distance. However, if object A exerts a force on object B will simultaneously exert a force on object A, which is equal in magnitude, opposite in direction. Please, can I get responses? Are you okay with this? All right, great. I'm glad we're okay with that. Let's go to, now we go to charges. Let's go to charges. Then I think from here, it would be one question on electrostatics itself. I'm going to help you digest the multiple choice, then give you time to deal with the structured one. Sketches 1, 2, and 3, not drawn to scale, are different ways in which 3-point charges are arranged. The charges are identical in magnitude, and the distance d between the charges are the same. Okay, let's see something. What's the difference? Charge in 1, let me use a highlighter. In 1, what do we have? Positive. All right. Positive, negative, negative. Okay. You know what, guys? Okay, let's see. Let's read the question. Negative, positive, okay, that. And this one is at an angle of what? 90 degrees. In which of these sketches with the magnitude of the net electrostatic force experienced by the positive charge? All right. Positive. We're focusing on the positive. Let me put a red on it. I don't even want to go look at the answer. Positive. We're looking at this one. We're looking at this one. And we're looking at this one. And the examiner says net electrostatic force. Let's go draw free body diagrams. All right. Ladies and gentlemen, please don't get confused. Let me do this. Let's label this as A, B, C. A, B, and C. A, B. But check the one that I've circled. That's the one we are focusing on, right? Now, let's draw the free body diagram A for number 1. Guys, consider this one. So forget about C for now. Let's consider these two. Positive and negative. What would happen? Attraction. We are focusing on A. A will be attracted, right? There we go. Can we call it F of B on A? All right. Now, check again. We're done with A, right? We're done with B. Guys, let's go to C. What do you notice about C? It is negative, and this one is what? Positive. What will happen again? This one will move towards what? D. But because of the distance, it will not be as strong as that of B. Check this. So let's call this F what? C. But my F net would be towards the right because both of them are going to the right, right? FB plus what? FC. That's number one. Let's go to number two. In case I lost you in number one, please catch me in number two. Look at this. Again, we are focusing on the positive one, which is now B. All right? Free body diagram. What do you notice? Let's deal with A and B. I'm just looking for my highlighter. Let's deal with that. Remember, our focus is on this now, the positive. What will happen? If it will attract and move that way. Okay? Can we call it what? FB on A? Or FA on B? Okay, it doesn't really matter now. FA on B. All right? What will it be? Okay, before we draw that. What about C? C will pull this towards its side. What are we going to have? It's going to be in this opposite direction, right? So what do we have? F what? FC. Our focus is on F net. Positive and negative. What do we have? FC minus FA. And because the distance are the same, it means the force exerted or the force experienced would be the same. So my answer will be what? 0. Now let's check number 3. Number 3. What do we have? Now, do you notice we are still focused on the positive charge? This one would go up, and this one would go where? To the right. Okay? Up and right. So, what are we going to have? Up and right. What do we have? FB. And what would we have here? F what? FC. But where is my resultant going to be? My resultant is going to be at an angle, which F what? F net. What is F net going to be? F net squared equals to what? FB squared plus FC squared. What is F net? F net is the square root of FB squared plus FC. Now, the question is, which one would be the greatest? Definitely it's not number 2. Number 2 is way, way smaller. Number 2 is 0. So number 2 is going to give me the smallest. My answer is either A or D. But the question is, which one is the greatest? Is it 1 or 3? Yes, Texan says 1. And I agree. 1 will be the greatest. Do you notice 3? We still have to find the square root, which brings the number down. It's just addition. And just like I did with this, now you can use, it's FB and FC. You can simply use numbers. 5 plus 5 would give you 10 on top. All right, 25 squared is 25 plus 25 would give you what? 50. Square root of 50 is about 49. 7 comma something. So the greatest is at 1 and the smallest is at 2. So A is our correct answer. I hope it makes sense, guys. Very lovely question. Did it make sense, everybody? So the free body, you see again, it's like we're just continuing Newton's laws when we get to electrostatics. Please, can I get responses? It's either yes, you okay, or no, you're not okay. Awesome. So please, when it comes to multiple choice, guys, this is how we address multiple choice. It's what tests your content the most. All right. Thank you, guys. Do you want to do this one? Let me do this one again for you. I want you to do more structured questions. 2 identical resistors X and Y, XY3 3. I don't know why I'm saying 2. All right. Are connected as shown in the circuit below. If the power of X is P, then the power in the Y. Let me use this to summarize electricity again. All right. This is doing ESCOM's job. Okay, guys. What happens here when current comes here? Oops. Current is going to come here, right? Good. We're going to have total current here, I total. But what happens when current gets to these two? It's divided. And because the resistors are the same, current will be divided into half. So what do you have? I over 2 and I over 2. I hope it makes sense. All right. The examiner says if the power in X is P. Remember they said 3 identical what? It means we have R, all these R are equal. Let's go calculate the power in X. Power in X using I and R. P equals to what? I squared R. You remember that formula? Let's call this Px, which is equal to what? P. Let's go calculate the power in Y. What do you see? What's my current? Power in Y. We are still using the same formula, right? Power in Y equals to what? I squared R. The current in Y. But what's the current in Y? It is I over 2, all what? Squared, multiplied by what? R. Okay. Let's simplify. What do you have? I squared R over 4. But hold on. It's like I've seen this I squared R somewhere. It is the power of X, which is P. So what do we have if we were to replace it? P over 4. Does it exist? Yes. B. It's a quarter of the power because current is divided. So current is divided and then you are squaring that current, which gives it over 4. Did you guys get the electricity one? If you got it, just say ESCOM yes. Let me know if it's okay. Or you'd like, I think this is just the simplest explanation that I could give. But if you are lost, let me know. So always remember that this is a parallel connection. And what do we know about parallel connection? If you remember the acronym we use, PAID. Parallel are current what? Dividers. Okay. We good? What is this Udefa saying? All right, guys. Now, I think we've done something like this. We've done inclined force and whatnot. I want us to. This is now structured. Let's work with this one quickly. Let's work with this one. We've done the inclined force. I'll send the PDF over. You can just practice other questions. But let's try this one. Let me give you 6 minutes or so. Now we're looking at electrostatics. Let me give you 6 minutes to try. Please give it your best shot. Read, interpret, use your formula page. All right, use your formula page quickly. 7 minutes. Talk to me if you are lost. Let me know. Are you stuck or you're winning? Okay, Jolene, thank you. Texting, I lost, right? Or you're following BB? BB says almost there. Dash, or are you lost or almost there? Okay. Amatula, Amod, talk to me, people. Either you are lost, done, or almost done. It's one of the three. Okay. All right. A lot of us are lost. And that's time up. Okay, let's check together. Let's look at this together. So it's important that we follow this lesson very, very well. Okay. Now, in figure 1 below, the two identical negative point charges are placed a distance x meters apart. The charges exert an electrostatic force of 1984. All right, so we have these two, and we're saying the force between them is 1984. Probably the year some of you, oh, you guys were not born. 1984. Maybe that's why you're all lost. Okay. In figure 2, the charges are separated a further 0.8 meters. That's why you have x plus 0.8. The electrostatic force now exerted on each other is a magnitude of 124. Quickly, do we understand why F is actually decreasing? F is decreasing because the force is inversely proportional to the square of the distance. The further they are apart from each other, the smaller the electrostatic force. State Coulomb's law. Oh, that's easy. The magnitude of the electrostatic force between two charged objects, that you know already, right, is directly proportional to the product of the charges and inversely proportional to the square of the distance between them, not their centers. So that I'm leaving for you to deal with. Calculate the distance x. Ooh. Okay, guys, we don't know anything, but I see that we have two identical, and they give us F. My dear learners, it looks as if we are all lost. But let's see. What can we get, even if we don't know what we're doing? Let's go find an expression for F. F equals to what? K, Q1, Q2 over R squared. Do I know my F? 1984. Okay, let me just leave it as K for now. Now, these charges are identical, so it's QQ. So can I say Q squared? What is the distance between them? X squared. Let's cross multiply. What do we have? KQ squared equals to what? 1984 X squared. We stuck. All right? KQ squared, we stuck. Let's go to the second one. Let's do the same thing. What is my F? 124 KQ squared. What is my X now? What's my distance? X plus 0.8, all what? Squared. Can we cross multiply? What do we have? K q squared equals to what? 124 multiplied by x plus 0, 8 squared. Are you aware of where we are right now? Two equations. But what is this? KQ squared. What is this? KQ squared. Can we equate them? What are we going to get? 1984 x squared equals to what? 124. Can I expand that? No, don't expand. Don't expand. I want to show you something nice. X plus 0, 8 squared. Are we okay up to this point? Don't expand when you get to electrostatics. I'm going to say, but how are we going to do it? Watch what I'm going to do. Let me write it on the next page. Okay? So 19, you have it down. 1984 x squared, because I don't want us to expand. 1984 x squared equals to what? 124 x plus what? 0, 8. Let's put all the ones with the x on the same side. Let me do this to make it easy for you. Let's divide both sides by 1984. What do we have? X squared equals to what? 124 x plus 0, 8 squared divided by 1984. I need us to get the one with the x onto the left. What do? We divide. All right, Tess, we'll check if your answer is correct. So I'm going to have x squared. We divide both sides now by x plus 0, 8. X plus 0, 8 squared equals to, you see, I've not even used a calculator. Now, according to mathematics, check this. A squared over b squared can be written as a over b, all what? Squared. So what would I have? X over x plus 0, 8. It's mathematical. Instead of expanding, 1984. What do? Look for the square root of both sides. What do I have? X over x plus 0, 8 equals to the square root of 124. Do you want to give me an answer to that? We are now using a calculator. This is some good question here. X plus 0, 8. What's your answer there? Zero comma 25. All right. So what do? We can now cross multiply. X equals to x plus 0, 8 into bracket 0, 25. Can we multiply that in? X equals to what? 0, 25x plus, what is 0, 8 times 0, 25? 0, 2. Now, can we move this over here? It's going to be x minus 0, 25x equals to what? Now, this is 1x minus 0, 25, which will give us what? 0, 75x equals to what? 0, 2. What is x? 0, 2 divided by what? 0, 75. What's your answer? 0, 27 meters. Well done, Tesmia. Lovely. Are we okay? I hope it made sense. That the maths make sense. So guys, work with what you have and become creative about it. We know nothing, but we had F. So all we needed to do was just to, okay, let's see F. And then we saw that there were too many variables So we needed a second what? Equation. We good, guys? This is such a lovely revision. So you need to get back home over the weekend, go through this session again, go through the questions, remind yourself of the principles. Are we okay? Please, can I get a response? Anybody lost? You need me to just re-explain something there? If you factorized, you would have gotten the same thing, but it's just longer. And it's going to look very messy. You're going to get a quadratic equation, then you're going to factorize, and yeah, you still get there. But if you know this, then you make life a lot more easier for yourselves. Sweet. Thank you, guys. So I'm sure you enjoyed the question. All right. Let's see what we are supposed to do next. Calculate the magnitude of the charges. Oh, that is now easy. Because we know our x, we can actually use any of the equation. Do you remember any of the equation? Let's use this one. KQ squared equals to 1984 x squared. I think we can all calculate from there. KQ squared equals to what? 1984 x squared. What is Q squared? Is 1984. What is my x? 0.27 squared divided by K. What is K? 9 times 10 to the power what? 9. And all we need to do is to find the square root of both sides. What is the value of Q? So basically we are solving simultaneously. What is the value of Q? Confirm for me. 1.26. 1.27 times 10 to the power negative 4 columns. Confirm? Is it solved, Bibi? All right, great. So guys, this is how we deal with all our questions. Okay, I'm going to share this PDF. I've got some other lovely questions, multiple choice that we need to do. I need to save my recording, Load shedding would hit just now. However, here's another one. Please, let's walk through again. When you see the word net, you need to draw your free body what? Diagram. So walk through this. We're going to complete that. This is cost of electricity. I can try to do this offline for you and send you the link just to watch it. Multiple choice. There's something I want to just do, my grade 11s. When you receive this, I want to quickly explain something. I have an inclined force there. Electrostatics again you use Newton's laws here with strings. Okay, what is the question? All right, grade 11s, I want to cancel something here. In the diagram below, the battery has an EMF of 13.5 volts. I'm canceling this, so take note. This is cancelled for you. In grade 11, we don't do internal resistance, so I'm just removing that. But every other thing, we'll leave it like that. So we work with, all right, let's do this. Let's just say the battery has an EMF of what? 12 volts. That's the 12 volts there. So don't worry about the 13.5. Yes. Yes. When I send the PDF, it's going to appear just like this, scratched out. So we're saying we are not using what? Internal resistance. I wanted to work with the principle. We are just using what? 12 volts. All right? Yeah. Every other thing. That's the only thing that takes it to grade 12. Otherwise, everything else is. Just that one statement is what leads us to grade 12. All of this is grade 11. All right, electrostatics again with graphs. It's quite a lot of questions that you need to use your weekend to prepare yourself. And you get all of this right, your grade 12 is just top-notch on this. And our next lesson, we can then mark a few of these and also start what? Paper 2. Guys, I hope you learned one or two things. I'm going to share the PDF quickly with you. Was it okay? So once you get the PDF, please start working and walk through so that we know that our paper 1 is done. I'll get some more motion questions as well for us to do. Okay. All right, guys. Got to save my recording. Let's go.